Paper 1 2019 then. Question number 8.1. So this is ethanol, so you could draw it out as C2H5OH or CH3CH2OH, either way, but it's important, as I explained on a previous question about alcohols and water. If you're coming to draw it, then you must draw delta plus, delta minus on the H and the O respectively. You've got to draw two lone pairs on each O. You've got to draw the hydrogen bond between a lone pair on an O and an H on separate molecules, and you've got to put the OHO in a line. Boiling points of ethanol and methoxymethane. It says what methoxymethane is. CH3OCH3. So ethanol in the molecule, has it got an O bonded to an H, an N bonded to an H, or an F bonded to an H? Yes, it has. So what that means is there's a large difference in electronegativity between the O and the H, or the N and the H, or the F and the H if they were in there. And that large difference in electronegativity sets up large delta plus and delta minus within the molecule. That creates a great attraction, a large, strong attraction between a delta plus on an H on one molecule and a delta minus, or the lone pair of electron, on a N, O, or F in a neighbouring molecule. That's called a hydrogen bond. So ethanol has hydrogen bonds. They're strong. They need a lot of energy to break them. That's why it's got a high boiling point. Whereas methoxymethane hasn't got an O bonded to an H, or an N bonded to an H, or an F bonded to an H. The O is between two CH3s. It's bonded to a C, so you haven't got big delta plus and delta minuses. You will get some delta plus and delta minuses between the C and the O, because O is still electronegative, but you're not going to get the big delta plus and delta minuses as in hydrogen bonding. Therefore, you'll get something called dipole-dipole attraction, which is stronger than van der Waals attraction, but nowhere near as strong as hydrogen bonds. So your answer is hydrogen bonds in ethanol, dipole-dipole intermolecular bonds in methoxymethane. Hydrogen bonds are stronger than dipole-dipole attractions. And finally, a shape of molecule. Draw the shape of POCl3 and the shape of ClF4-. So let's do POCl3 first of all and talk you through it. There's one P atom. So I'm going to pop that in the middle. It's in group 5. I'm going to put 5 electrons around it in its outer shell. Has it got any plus or minuses? Do I need to add any electrons or take any away? No, I don't. So I've got 5 electrons. Now, the difficult thing here is that an O double bonds. The reason it double bonds is because O is in group 6 and wants to gain 2 electrons. So it wants to put 2 into a share. So it double bonds. And so it's going to bond with 2 of the phosphorus electrons in a double bond. Now we count that, even though it's a double bond, we count that as one bond set of bonded pairs. So I've got a P to O double bond, which I'm counting as one bonded set of electrons, and then I've got 3 other Cl's to take up the to bond with the 5 electrons in total. It's going to form a tetrahedral shape, bond angle 109.5. Fine. Now the ClF4 minus ion, how does that work? What's the one of? There's one Cl, so that goes in the middle. What group number is it in? 7. Are there any electrons to add on or take away? Yes, there's a minus, so I'm going to add an electron on. So that Cl has got 8 electrons in its outer shell. 4 F's bonded, there's 4 bonded pairs, there's 4 electrons left over, 2 lone pairs. Will it be linear? Not in terms of drawing the shape, because I've got 4 bonded pairs and 2 lone pairs. 4 add 2 is 6, so when I draw the shape it's not linear. It might be linear when I describe the shape and just discuss the bonded pairs and ignore the lone pairs when I'm describing the shape. But I'm going to draw the bonded pairs up and down. So once you hit a total of 5 bonded pairs add lone pairs, once you get to 5, the 2 lone pairs repel as far away as possible and go up and down. It leaves the 4 Fs then in a planar shape in the middle. So that is square planar. So you draw it as a non-planar shape, but when you describe it as a planar shape because you don't describe the lone pairs. You can't see those. So I've got 4 Fs in a plane, square planar shape, bond angle 90. Now, that's taken from the mark scheme. I would prefer it if you put square brackets and a minus around it. I would remove a mark there if I were marking that, but that's the official mark scheme there, but I prefer square brackets with a minus. After all, it is a minus charged ion.